melts, so its surface area decreases at a rate of 0.1 inches square per minute. Calculate the rate of change of the volume when the radius is 12 inches.
So here we have our data, and we know that the snowball decreases at a rate of 0.1 inches square over minutes. We have a radius which is 12 inches, and they are asking us the rate of change. So here we know that d of t is the surface diameter, and d of t is the diameter of the snowball at a time t. And also we're going to use this formula, which is the surface area of a sphere, which is 4 pi times r squared.
Okay, now for the procedure. The first step is to find the expression that corresponds to dV over dt, which is the change we're looking for. Okay, so first we get the formula of volume for a sphere, that is 4/3 pi r cubed. Then we get the derivative, that is dV over dt, which equals to 4 pi r squared times dr over dt, which is the change we're looking for. Then we find the value for dr over dt, which is dA over dt, that equals 0.1 inches squared over minutes. That's the rate that the snowball melts, and that's the information that they give us. Then we also know that the formula for the area equals 4 pi r squared times dr over dt. Then we get the derivative, and we get that dA over dt equals 8 pi r times dr over dt. Then we substitute this value, because this is the data that they already give us, to 0.1 inches squared over minutes, that equals 8 pi times dr over dt. For the third step, we substitute to find dV over dt, which is dr over dt equals 0.1 over 8 pi r. Then we substitute the r, because that's the radius that they give us, which is 12 inches, and we get an approximate value of 0.000331. And then the final step is to find the rate of change, which is dV over dt, that equals 4 pi r squared times dr over dt. Then we substitute the values that we already know, and we get the dV over dt, which is the rate we're looking for, equals to 0.599 inches cubed per minute.
So kids, now you know. What is implicit differentiation important for? Things that matter. Real life applications. How fast does a snowball melt? Super important. Politics, forget about those things. Economics is what is trending today. Hot stuff. How fast does a snowball melt? You can easily find it using implicit differentiation. So please, think about your future, think about your careers and your own lives. What do you need to be happy? Implicit differentiation. Thank you.